What's up, everybody? Welcome back. Today we're doing Module 5, Lesson 10, and it is your favorite Mr. Grossart. So today what we're going to be doing is that we're going to be finding the area of rectangles basically by using fractions, which is something we might have touched upon a little bit when we were in school. But I'm going to show you guys a super simple way of doing it today. I hope it's simple at least. It's simple to me. And it's really kind of very similar to drawing an area model, which is appropriate because we're doing area again. Okay? So let's take a look at the first one here. The very first one is actually quite simple to find the area, right? So why don't you take a minute real quick, give yourself a little practice, a little brain warm-up, pause the video now, and try and find the area of this, just kind of by using mental math. We can actually find the area very simply. Okay, so pause the video now. And we're back. All right. It must seem really weird for those of you who don't pause the video, for me to just be like, all right, anyway. So if we count up all the tiles, that's one way of finding the area. So we know that the area simply by counting is 1, 2, 3, 4, 5, 6. And if we use the length times width option, we're going to check our work, and 2 times 3 is, of course, 6. So we know the area is 6, right? So we can essentially just kind of skip count. 1, 2, 3, 4, 5, 6. So area is 6. We're going to put units squared, okay? Very, very simple. Now for this one, we have a fraction in here. So we're not really going to be able to just count the tiles like we're used to. I mean, I guess you could try, but you'll be making way too much work for yourself. So let's try a simpler method. So what I'm going to do is I'm going to create tiles, just like we call these little tiles. I'm going to create tiles in here, and then I'm going to work through it. So just watch what I do. Okay, so I'm going to have, okay, so that's a row of 3. And here I'm going to need to draw 2 and then like a half, right? So when we break it down, we're really splitting 3 up into 1, 1, and 1. And then same thing with 2, except we're splitting it up into 1, 1, and then 1 half. So now what we can do is we can use a very similar strategy to what we used in the previous example. So we're going to count the tiles. So 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. Okay? 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. So now up here we have to do the length and the width. So the length is 1/2. The width is 1. So 1 times 1/2, mental math. 1/2. 1/2. And then 1/2. Okay, so now what we're going to do is we're going to kind of count up all the totals. So we have 1, 2, 3, 4, 5, 6 ones. And then we have 1, 2, 3 halves. So that we're going to have to add the 3 halves. So what is this really? What is 3 halves? It's 1 and 1/2. So we have 6 plus 1 and 1/2. And we can really just solve this mental math. So we know that our area of this is going to be 7 and 1/2 units squared. Okay, so that's how you use tiling to find area. We call that method tiling. So we're basically breaking it down into tiles by decomposing the whole numbers into units of 1. And then we're going to be using the fractions as well. So in other words, 3 gets broken down into 3 ones, so 3 columns. And the 2.5 gets broken down into 2 rows of 1 and then a row of 1/2. All right, so we're decomposing these numbers. All right, let's skip ahead because this is going to be slightly different. So this lesson kind of covers a couple of different things. So this is just the other thing you're going to see in this lesson. And then pretty much you're going to be off doing your problem set. I'll also attach a video, of course, like I always do, an additional video in case you think that Mr. Grossart is talking a gibberish. So let's go ahead and do the next one. The rectangle is composed of squares that measure 1 1/2 inches on each side. What is the area of the rectangle. So in other words, that it's saying that each of these little squares here is going to be 1 1/2 on each side. So essentially what we have to do is that we have to find the area of the whole thing. What we're not going to do is go, oh, 1 1/2 times 1 1/2 and say that's your answer, because that's not what it's asking you. It's telling you that the area of this is 1 1/2 times 1 1/2, right? So once we find the area of one tile, we can then know the area of the rest of them. So watch the 3 steps. These 3 steps are going to change your life. Step 1, find the area of each tile. A tile is the smaller unit. It's not the whole thing. So we're going to find the area of the tile, okay? Then we're going to multiply the area of the tile by basically the total number of tiles. So here we're going to have 1, 2, 3, 4, 5, 6, 7, 8 tiles. So whatever the area of this is, times 8, and that's going to be our answer. Okay, so let's go ahead and do 1 1/2 times 1 1/2. This is step 1. So I'm going to make these improper fractions, which is going to be 3/2 times, right? 3/2. So 3 times 3 is 9. 2 times 2 is 4. So then what is 9/4? Is going to be 2 and 1/4 left over, because 4 times 2 is 8 plus 1 is 9. So 9/4. Okay, so we know that this is 2 and 1/4. And if this is 2 and 1/4, it means this is 2 and 1/4, and this, and this, they're all 2 and 1/4. So if I want to find the area of the whole thing, I'm essentially going to be doing 2 and 1/4 times 8 tiles. So let's go ahead and do this the way that we've learned. And I'm going to do, well, there's a few ways we can do this. I'll just do it this way. I'm going to do 2 times 8 is 16, and then 1/4 times 8 is going to be 8/4, but of course I can't leave it that way. 8/4 is 2, right, which is 2. I'm going to put in parentheses, that's 2. So then 16 plus 2 is the area of the whole giant rectangle is 18 units squared. Okay? That's pretty much it. So you're going to see problems just like this on your problem set and homework. If you have any questions, shoot me a message. There also is my chart's going to be posted, so you don't forget. You can look at this as much as you want, and another video is going to be linked as well. All right, guys? Peace!